So good morning, everyone. Once again, welcome to Physics by Physics. And in this C.T.P series, we are going to take some problems based on electric dipoles. So we were discussing the electrostatics part, and now we are going to take examples based on electric dipoles. So let's see. We will see question based on electric dipoles. So we will take dipole and polarization. Just see. So what are the formulas and concepts that we are going to use in case of electric dipoles? So let's summarize those formulas. Electric dipoles. So assume we have an electric dipole that is placed along z direction. Now assuming dipole is placed along z direction. This is the dipole P, where dipole moment P is given as Pz cap. P is the magnitude of the dipole moment and direction is z cap. And if you have to see what will be potential and electric field at point P. So that potential is given by V as a function of R theta is given by, you have to remember this formula. I'm writing it in spherical polar coordinate, 1 by 4 pi epsilon naught P cos theta by R square. This is the potential due to dipole in spherical symmetry. This formula is in spherical symmetry. Then you can find electric field E. You know that E is minus of gradient V. So if you take electric field, this is given by P by 4 pi epsilon naught R cube 2 cos theta R cap plus sin theta theta cap. This will be the electric field due to dipole, where in spherical symmetry this is R cap direction and this direction is theta cap. So it means E has two component of the electric field. E is given as ERR cap plus E theta theta cap. So what will be ER component? Just see, this will be given by 2p cos theta by 4 pi epsilon naught R cube. And what will be E theta component? This is given by P by sin theta 4 pi epsilon naught R cube. So this is ER and E theta component. Now let's see resultant of E. This is the resultant field E, which makes an angle alpha with R cap. So what will be the magnitude of the field at that point? Magnitude of field is under root ER square plus E theta square. And if you find this value, you will get P by 4 pi epsilon naught R cube under root, what you will get? 4 cos square theta plus sin square theta. Sin square theta is 1 minus cos square theta. So this will be 3 cos square theta plus. So this is the magnitude of field at this point. And what will be direction with respect to r cap? So direction is given by tan alpha, and this is E theta by ER. So if you divide it, that is half tan theta. So alpha is given by tan inverse half tan theta. This is direction with respect to r cap. So you have to remember this formula in a spherical symmetry. We can also write this in coordinate free form. So this potential can also be written as 1 by 4 pi epsilon naught P dot r cap by r square. This is coordinate free form of potential, because P dot r cap is simply cos theta. If you calculate P dot r cap, this value will be P cos theta, because Z dot r cap will be P cos theta. And if you find the electric field in coordinate free form, this electric field is given by 1 by 4 pi epsilon naught r cube. This is 3 P dot r cap minus P. So must remember this formula in coordinate free form also. Note it down. So this is the summary of electric field and potential due to dipole. If you know coordinate form, you can also find the x, y, z component of the electric field. So you can easily find x, y, z component of the electric field also. Now we will see dipole in an external field. When you have a dipole in an external electric field. So first you have field is uniform. Field is uniform. So you will see net force on the dipole will be 0. Net force on the dipole is 0. And it will experience torque about the center, and that is given by P cross E. And this torque will try to rotate the dipole in field direction. Whenever an electric dipole is placed in an external field, this torque will try to align the dipole in field direction. B is non-uniform. If field is non-uniform, then net force is given by this is P dot del E. So P dot del is an operator. If you operate on E in component form, you will get the net force. And torque is still given by P cross E. So must remember what is net force and torque due to dipole. Now we have to see potential energy of the dipole. Potential energy of the dipole. And that potential energy is given by minus P dot E. Minus P dot E. And using this, we can find interaction energy of two dipoles. Interaction energy of two dipoles. So if you are considering this to be one dipole P1, there is another dipole P2, and they are placed r distance apart. So what will their interaction energy? So it is potential energy of one dipole in an external field of other dipole. So if you use the coordinate free form, so this will be given by minus P1 dot E2, and that will be same as minus P2 dot E. So that is potential energy of one dipole in an external field of other dipole. And if you calculate this, this is 1 by 4 pi epsilon naught r cube. You will get P1 dot P2 minus 3 P1 dot r cap, and then you have P2 dot r cap. Clear? So you have to remember these formulas. So that is the interaction energy of the dipole. So this is the summary for electric dipole. Now you have to solve questions. So let's see. Now start with question number 1. First see this figure. Just see in this figure, this is a dipole. One dipole is placed here. Then you have a 2-point charge. This is plus Q at L distance away. At coordinate LB is plus Q, and coordinate, this coordinate is L minus B. Then you have to see what will be the, in this case, it is given that an electric dipole moment is given as Q into B. I cap is placed in the vicinity of two charges plus Q and minus Q respectively. The electrostatic potential at this point. So you have to find potential at this point. Let's see what will be potential at this point. So in this case, question number 1. So potential is, you have to find potential due to each dipole, this dipole, and then due to point charge. So dipole moment P is given as QB I cap or X cap. So when this is the direction of the dipole, what will be the potential along this? So we have, when you are applying the potential formula, you have to assume dipole is along Z direction. So along Z direction, when dipole is placed along Z direction, along this point, this is the Z direction, theta will be 0. So what will be potential due to dipole? V dipole. So this is given by 1 by 4 pi epsilon naught P cos 0 by L by 2 whole square. L by 2 whole square. And this will be given by 1 by 4 pi epsilon naught. And you will get 4p by L square. This is the potential due to dipole at point L by 2 and 0. Okay? Now what will be potential due to plus Q charge? This is given by 1 by 4 pi epsilon naught Q by, now you have to consider this distance. So this is L by 2, this is B. Under root L square by 4 plus B square. And what will be potential due to minus Q? This is given by minus 1 by 4 pi epsilon naught Q by, again same distance, under root L square by 4 plus B square. So potential at point A. So what will be potential at A? So this will give you V dipole plus potential due to plus Q charge. So if you add these two will be 0, this will give you what? V dipole is P by pi epsilon naught L square and P is Q into B by pi epsilon naught L square. So if you see the options here, just see the option. So in this case, option C is correct. QB by, because dipole moment is given. So potential is QB by pi epsilon naught L square. So answer is option C. Option C is correct here. Clear? So that is question number 1. Note it down. Now you have question number 2. Just see. Two electric dipoles P1 and P2 are placed initially. Let's see, X, Y, Z. This one is placed at 0, 0, 0. Let's say this is dipole P1. And another is placed at 1, 0, 0 with pointing in Z direction. Both are pointing in Z direction. So this distance will be 1 unit. And without changing the orientation of dipole, P2 is moved to 0 to 0. X, Y, Z. This is P1. This is P2. So you know that potential is inversely proportional to R cube. You have to see the potential energy, the electrostatic potential energy, that is interaction energy of two dipole. So U is inversely proportional to R cube. So this is the first configuration and this is second configuration. So what will be this ratio? U2 by U1. So this will be R1 cube by R2 cube. So this will be 2. So R1 is 1 unit. And this is 2 unit. So that will be given by 1 by 8. So this ratio will be 1 by 8. So option D is correct. Option D is correct. Is it clear? So that is question number 2. Now see question number 3. Now we have question number 3. So let's read the question first. For an electric dipole with dipole moment P naught E Z cap, where Z cap is the unit vector in Z cap direction. Magnitude is P naught, is placed at the origin. P naught is a constant of appropriate dimension. Ex, Ey, Ez are unit vectors. Then you have to identify which one is correct. Option 1 is potential falls as 1 by R cube. A spherical surface centered at the origin is an equipotential surface. Electric flux through a surface enclosing the origin is non-zero. And radial component of E is 0 on the XY plane. So we have to verify all these results. So let's see. Let's verify. So in this case, question number 3. Placed at the origin. Dipole is placed at the origin. X, Y, and Z. So let's say I'm assuming this is plus Q charge and then there is a minus Q charge, so that dipole moment is in this direction. So how potential falls as 1 by R cube, where R is the distance from the origin. So this we have already seen that at R distance away, potential is inversely proportional to R square. So option A is incorrect. Option A is incorrect. Then option B. This option is incorrect because potential is, option A is incorrect. Option A is incorrect because V is proportional to 1 by R square. Now if you have a spherical surface centered at the origin is an equipotential surface. If you draw an sphere, so at different point potential will vary. So that option is also incorrect. Now C part, the electric flux through a spherical surface enclosing the origin is non-zero. No, it will be 0. So option C is also incorrect. Now see, the radial component of E is 0 on the XY plane. And what is the radial component? I have written ER is 2p cos theta by 4 pi epsilon naught R cube. And in XY plane, theta is pi by 2 in XY plane. So cos 90 is, cos pi by 2 is, so ER component will be 0. So fourth option is radial component of is 0 on the XY plane. So this option is correct. So this option is correct. So option D is correct in this case. Clear? Now see next question. Let's see question number 4. Again, you can see question number 4. So for a point dipole of dipole moment P, again P is PZ cap located at the origin. Which of the following is correct? The electric field at 0B0 is 0. This is on y-axis. The work done in moving a charge q from 0B0 to 00B is this value. The electrostatic potential at on x-axis is non-zero. If the charge q is kept at 00B, it will exert a force of magnitude QP by 4 pi epsilon naught B cube on the dipole. So you have to verify these options. So let's see. Question number 4. Question number 4. So again, same, I'm taking the same symmetry that this is X, this is Y, and this will be Z direction. And this dipole is placed along Z direction. P is given by as PZ cap. Now electric field at 0B0. This point is 0B0. So A part at 0B0, theta is, what will be theta? Theta is pi by 2. So electric field is given by 1 by 4 pi epsilon naught. This will be B cube 2 cos pi by 2 r cap plus sine pi by 2 theta cap. So cos 90 is 0, but sine 90 is 1. So E is given by 1 by 4 pi epsilon naught B cube theta cap. And at this point, theta cap is downward. So this is the direction of the electric field. So electric field is non-zero. Electric field is non-zero. So option A is incorrect. Now see B part. Let's check. What will be work done in moving charge q from 0B0 to 00B? So in electrostatic field, work done is independent of path. It only depends on potential difference between 2 points. So this is given by, you are moving from this point to this point, 00B minus 0B 0. So at this point, theta is 0. And at this point, theta is pi by 2. So we have to use the potential formula. So I'm taking 1 by 4 pi epsilon naught common. So this is P cos 0 by B square minus P cos 90 by B square. So this is PQ by This is PQ by 4 pi epsilon naught B square. PQ by 4 pi epsilon naught B square. So this option is correct. Now let's check other options also. C. What is the electrostatic potential at B00? So again, at B00, theta is 90 degree. So this will give you potential will be, because potential is 0. Because P cos theta by cos 90 will be 0. So option C is also incorrect. Now, if the charge Q is kept at 0, 0B, it will exert a force of magnitude this. What will be electric field at this point? Now, electric field will be at 0, 0B, theta is 0 degree. So what will be electric field E? E is given by 1 by 4 pi epsilon naught B cube 2 cos 0 r cap plus sine 0 theta cap. So this will give you, P is here, cos 0. So this will be 2P by, if you are to write the magnitude, because sine 0 will be 0. So this will give you 2P by 4 pi epsilon naught B cube. So force is, magnitude of force is given by Q into E. And that will be 2PQ by 4 pi epsilon naught B cube. But in this option, it is given that QP by 4 pi epsilon naught B cube. So this option is also incorrect. So only option B is correct. Clear? So in today's C.T.P series, I have taken some question based on electric dipole. There are some more questions so that you have to solve. Dipole in an external field. This is dipole in an external field. And then we will see about these are the some question based on the electric dipole. And then we will focus on the polarization case. So in next lecture, I will take dipole in an external field. And then we will talk about polarization. Clear? So meet you in next lecture on Monday. We will take these classes on Monday, Tuesday, Thursday, Friday and Saturday, 11 a.m. Okay. Thank you, everyone. Thank you.